Hello coders, welcome back to Python Scholar. I'm Salman Khalik and today we are starting a new series focused on understanding Python's random module. Python's random module is one of the most useful and frequently used modules, especially in data science, simulations, and many more interesting areas like game development. So let's get started. Python's random module allows us to generate pseudo-random numbers. Now you might be asking, what are pseudo-random numbers, right? I'll come to that in a bit. But before that, let's see how we can start using this random module. The great thing about Python's random module is that it's part of Python's standard library. That means you don't need to install it separately if you have Python installed. It comes along with Python itself. Let's move to our Python environment to start using this module. To start using this module, we first need to import it into our Python script. Here's how to do it. Simply write import random at the beginning of your script, and now you have access to all the functions that the random module provides. So we will start with some basic functions provided by random module. The first one we are going to start with is random function. This function returns a random float number between 0 and 1. It's very simple to use. After importing the random module, you simply call random.random. So when you run this, you will see a random float printed out. Here you can see that 0.2, 40955, and so on. So this number would always be between 0.0 and 1.0. Let me run it again and see what number we get. We get a different number. So similarly, you can see that if I keep on running it again and again, keep on getting a new float every single time because there are infinite number of floats between 0 and 1. Keep one thing in mind. If you want the exact same number that you got in the first place every single time, then you need to set a seed value. And how to set the seed value, I will cover that later in this tutorial. So stay tuned. Now, we just got a random number between 0 and 1. What if I want a number between any range? For that purpose, we have the second function I'm going to cover is the uniform function. So this uniform function, what it does is it takes two arguments. The first one, here you can see that it takes A and B, which means it takes two float arguments. That means this is the starting. So I can give the starting and ending value, and it's going to give me a number between that range. So if I put in 2, 10, which means now it's going to give me a number, a random number between 2 and 10. So if I run it, you see I get 2.8. If I run it again, I get a different number, 9.96. If I run it again, you see every time I get a different number. If I want the same number again, I have to set the seed value. As I told you before, I will show you how to set the seed value later. So both of these functions that we covered, they give you a float number. That means a decimal number. What if you need an integer? Do we have a function for that as well? Yes, we have a function for that, and we call it randint. So this function, what it does is it's going to give you a random integer between the range from 2 till 10. And keep one thing in mind. Let me run it. See, now I'm getting an integer number, 10. And 10 is inclusive, 2 is inclusive. So keep that in mind. So if I keep on running, it will keep on giving me random numbers. So you see, I get 10 two times. But that's a coincidence. Okay, so since we have very limited number of integers between 2 and 10, we will see some repetitions. But if these are floats, then most probably you will not see the same number again if I keep on pressing it in this tutorial, because there are infinite number of floats between any like 1 to 2 or 0 to 1. There are infinite number of floats. So let's get into some sequence related functions. What does that mean? That means if I give you a list or a tuple or a string, can I pick random numbers or random values from those list, tuple, or string using this random module? We can do that. So we have different functions for that. So we are going to start with the first function, which is choice. So for that, let me first introduce a list of fruits. So I will create a list of fruits. So my list, I will say, and I will create put some apple in my list. Let's put maybe strawberry in it, and then I'm also gonna put maybe cherry in it, and then I also see. And I'm also going to put maybe dates in it. And then I'm going to put maybe banana in it. So this is my list. And in this particular list, you can see I have apple, I have strawberry, I have cherry, I have date, and I have banana. So I have 5 different fruits in my list. Now, I will use the choice function. You can see we have 2 different functions. One is choice and one is choices. So let's do choice first, and then I'm going to show you how to use choices as well. So for that, I will give my list as an argument over here. So I will say my underscore list. And now if I run this, it's going to pick a random item from the list, strawberry. Let me run it again. It picks up banana this time. If I run it again, it picks up cherry. So you can see this particular function is very handy. And similarly, if you want to pick more than one fruit from this particular list, you can definitely use the choices function. The choices function takes the list as an argument. Let me use this as choices. So it will take which list you want as an argument, and then you have to tell the k value. So this k value is going to be how many fruits you want it to pick from this particular list. I will say 2. And if I run this, now it's going to give me a list of 2 different items from the list. What you see over here is it does repetition, which means first it's going to pick one item, then it's going to use the same list all over again and pick another item, which means there are chances that repetition can happen. So over here, let me run it again. You see cherry and strawberry. If I run it again, you see I have apple and date. And here, if I run it again, cherry and strawberry. So you get the idea. Here you can see the choices function basically gives you repetition as well, which means it will not exclude the things that you have already got in the first attempt, which means repetitions can happen. So what if the repetitions are not allowed? Do we have a function which can do that? Yes, we have. So if I don't want repetitions to occur, I would be using the sample function. So this sample function is very similar to this choice function. And here you can see that how to use this sample function. It's pretty simple. It will take my list as an argument and the k value. Now it will not repeat the same elements. So here I get date and apple. Here I get apple and date, and so on, which means if I have already picked banana, that means my next attempt, I will not be using banana. It will exclude banana and it will pick from the rest of them. So this is what you would see. And for example, if I increase the k value, let's say the k value is 4, let's see if it repeats. You see it pick 4 different fruits. But whereas if I use choices, you can see repetition can happen. You see banana, apple, strawberry, and banana all over again. So the banana is repeated. Here you can see date, apple, cherry, and cherry. Then again, you can see strawberry, cherry, apple, and date. This is a coincidence. Banana, strawberry, apple, and banana all over again. And you get the idea. So choices is when repetition is allowed, and sample is when the repetition is not allowed. If I sample, you see I get all 4 different fruits. So you have to keep this in mind. Now, let's address the elephant in the room, pseudo-randomness. In computing, generating truly random numbers is quite complex due to the deterministic nature of computing. So we use something called pseudo-random numbers. These numbers appear to be random, but they are generated in a way that they can be reproduced if you know the so-called seed values used. The algorithms used to generate these pseudo-random numbers are designed to provide a random-like distribution and sequence of numbers. So, why do we use pseudo random numbers and not truly random numbers? Well, pseudo random numbers are often sufficient in simulation or testing scenarios where we want repeatability. For example, while debugging your program, you may want to generate the same sequence of random numbers to reproduce a particular scenario. This is the beauty of Python's random module. It provides functions to generate pseudo random numbers, allowing us to simulate randomness and maintain control over it when required. Let's explore some more functions. For example, like if I want to shuffle the fruits in my list and I want to change their order randomly, can we do that? Yes, we can. So we can use the shuffle function. But keep one thing in mind. all the functions that I showed you previously, they were not affecting my original list. But this shuffle function does all the changes in place, which means it's going to affect the original list. It's going to change the order of the original list. So be very careful about that. So it's going to take my list as an argument, and now what I'm going to do is I'm going to print my original list, because if I try to print this, it's not going to do anything. So it's most probably it's going to return none, because the output for this is nothing. It is just doing the changes in place, which means I can do this random stuff, or in fact, well, let's print it and see what output we get. And I'm going to print my original list to show you the changes in place. So let's run this and see if it shuffled the order of my original list. Here you can see that. Now banana is my first element, apple was my first originally, cherry is my second element, but strawberry was my second element originally. And you get the idea. So it changes the order and it does it in place. So you have to keep that in mind. So if I reorder it again, you can see that. If I reorder it again, you can see that. Next function I'm going to talk about is the random range function. This function returns a randomly selected element from the range created by the start, stop, and step argument. Just like in list slicing, we use start, stop, and step arguments, we are going to use those arguments here as well. Here's how it works. So, first of all, I don't need this list. So, let me get rid of this list. And I also don't need to print this list since list is not needed. And let me get rid of this. Now, what I'm going to use is rand range function. And this function is going to take a start value. So I will say start. Then I'm going to separate the end value, let's say 10. And then I'm going to give a step value. So let's say 2, which means this is going to select a number from even numbers between 0 and 10. And 10 will not be inclusive. So be very careful about that. Okay, so if I run this, you can see it gave me 6. If I run it again, it gave me 6 again. If I run it again, I got 4. If I run it again, I got 4. If I run it again, I got 6. Seems like it's stuck between 4 and 6. Now I got 8. So it will give me numbers in this particular range, and the step size is 2. That means 0, 2, 4, 6, 8. 10 is not inclusive. Be very careful about that. Okay, now we have covered so many different functions, but the thing is, we want repeatability. That means so far, if I click this run button, I get a random number every single time. I got 0 this time. What if I'm doing an experimentation, and in that experimentation, I want to keep all those randomly selected things to be exactly the same sequences or exactly the same values? What should I do? As previously I have told you, we can set the seed value. Seed function is a pretty straightforward function. So this function is used to initialize the random number generator. So what is happening in the background is whenever I'm using any function from the random module, what it does in the background is first it picks up a random seed value, and then based on that seed value, it gives me a particular result for that function. So what if I fix that seed value? Then I will keep on getting the same number over and over again from that particular function. And this is what the seed function do. So if you use the same seed value, so this is often used in testing when you need repeatability. Let's see it in action. So here I can introduce a seed value, maybe here. I can set up any value. Here you can see that this value can be an integer, a float, a string, bytes, byte arrays, or none type, all of these types. So I'm going to go with number 22. This is the number usually I go with, and you can pick up any number you want. You would see different people use different numbers. Some people use 1, some people use 100, some people use 42. I always go by 22. So it doesn't matter which number you pick. So if I want my results to be exactly the same over and over again, I always keep the seed number to be 22, which means whenever I'm using this random number and I want repeatability in my experiments, I stick with this number. So if I run this, you can see I get 2. But that means by default, my previous attempt, my seed value was 22, maybe, and it was giving me 2. Now, if I keep on running this particular random function, you see it is not changing the answer. It is continuing to give me the number 22 as an answer. What if I change the seed value? Anything is going to happen here. So if I do 2, I get 0. That means different seed values gives you different answers. There can be multiple seed values which can give you the same answer, but that's just a coincidence. Okay. because we have a very limited number range here. So if I do this, I keep on getting 0, it doesn't matter. But what if I want the 2 back? I will use 22. If I use 22, I will get that 2 back. It doesn't work with only this function. We can try it with other functions that we learn. So let's use the random function. We learned the first one. So if I generate a random number here, 0.9582, so which means if I keep on running this code, I will keep on getting the same number again and again. What if I change this to 2? I'll get a different number, 0.956 or something. If I keep on running this, I keep on getting this number. But what if I want that same 0.958 something back? I will use the seed value 22. And you see that. This is what the seed function does. Now we have covered some basic functions, some advanced functions, and things like that. Now we will get into probability distributions, which means can we pick a number from a particular type of distribution, like from normal distribution or Gaussian or exponential or some other type of distributions? We can do that. So here, first, I'm going to introduce a Gaussian function or simply Gauss function. If I want to keep the seed value this, you won't be able to see different values. So I will get rid of this random seed for now. So if I get rid of this, and now here I can use the Gauss function. So this Gauss function takes in 2 arguments. So it takes the mean of the Gaussian distribution. Here you can see that. Let's say maybe I have a mean of 0. And the second value it takes is the standard deviation. And that standard deviation, which is the sigma value, and maybe let's say it is 1. So now it will give me a random number from a Gaussian distribution which has a mean value of 0 and a standard deviation of 1. So if I run this, I'll get different numbers from that particular range. That means if I want to create a testing data for a particular experiment, like I want to figure out the height of some people in a particular distribution, usually height of people, it follows a normal distribution curve or Gaussian distribution curve, which means I can use this particular random function to generate that data. So it's a pretty handy tool. If I run this, you see, I get different values. Sometimes it is positive, negative, because it can be on both sides of the mean value. So that is not it. We don't just have the Gaussian function. We have a lot of different types of distributions that we can use here. This function we will be discussing is the exponential distribution, which is usually the function is named expovariate. So this function generates random numbers following an exponential distribution, which is often used to model the time between events in a Poisson point process. So the example would look something like this. I would say expovariate, that would be the name of the function, and it takes in one argument which we call lambda. And this lambda is usually in decimal, so I will do 1 divided by 5 maybe. So if I run this, now what is this lambda d variable here? So what exactly I'm trying to do in this case, we are generating a number from an exponential distribution with the mean time between events of 5 units. Exponential distributions are commonly used in operations research and industrial engineering to model waiting time. So this is how we can use the exponential distribution. Finally, I'll show you another distribution which is kind of like similar to Gaussian. It is the normal distribution. They are pretty much the same thing, but this function has a bit difference. I'll talk about that difference. So we call it normal variate. So instead of expovariate, this one is called normal variate. And it takes in the 2 arguments just like the Gaussian distribution, the mu and the sigma. So here you can see mu is a float and sigma is a float. So we have to define 2 arguments over here. So first one would be the mean. Maybe I will call the mean for this particular function to be mu would be the 0 function, and sigma would be 1. So I can define that. So this is pretty much the same thing. If I just do 0 comma 1 in this order, I know that mu comes first and 1 comes later. Since I'm giving these arguments in based on their position, I don't need to write their names. Like this one is mu, so if I use the keyword, if I forget about the order, then I can give the mu value after the sigma value. It doesn't matter which position I give them in, but if I don't give them, then I need to be very careful about their position. So this is usually the position. Mu value comes first, which is the mean value, and the standard deviation comes second. So if I run this, I get the value. Now you must be saying, we talked about Gaussian distribution. Why this normal variate is, if it is the same distribution, then why are we using it? right? So the normal variate function and the Gaussian function are very similar. The key difference is in the speed and accuracy of the two methods, with Gauss being slightly faster and the normal variate being more accurate for tails of the distribution. As always, the code from this tutorial will be available in the description. If you have any question or topics you want me to cover, let me know in the comments. Don't forget to like this video if you found it helpful.